SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe. You can download SpaceTime as a free twice-weekly podcast just about everywhere, including iTunes, Stitcher, Pocket Casts, Bytes.com, YouTube, SoundCloud, Audio Boom, and from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C. Coming up on SpaceTime, the incredible shrinking planet Mercury, Rosetta's grand finale, and while you've probably heard of a blue moon, have you ever heard of a black moon? All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
New data gathered by NASA indicates the planet Mercury is actually shrinking. The findings, reported in the journal Nature Geoscience, are based on a series of small, previously undetected cliff-like tectonic structures on the planet's surface known as thrust fault scarps. The images were taken by NASA's Mercury Surface Space Environment Geochemistry and Ranging spacecraft, better known as MESSENGER. The observations during the final 18 months of its mission to the planet nearest the Sun indicate that Mercury is still contracting today. During the closing months of the mission, MESSENGER's altitude was progressively lowered, allowing the surface to be imaged at much higher resolutions than previously possible. The study's lead author, Thomas Waters, from the Center for Earth and Planetary Studies at the Smithsonian National Air and Space Museum, says Mercury joins Earth as a tectonically active world. He says the data indicates new faults are likely still forming today as the planet's interior continues to cool and contract. Co-author Maria Banks from the Planetary Science Institute says these newly discovered small-scale thrust fault scarps are orders of magnitude smaller than larger scarps previously known to exist on the planet's surface. The larger, older scarps were identified in both MESSENGER and also older Mariner 10 images, and are seen as evidence for the global contraction of Mercury as its interior cools, causing the crust to shrink. The small scale of these newly identified scarps, which are only a few kilometres in length and just a few tens of metres in height, indicate they were formed relatively recently. That's because the constant, steady meteoroid bombardment of Mercury over billions of years would have degraded and destroyed structures this small had they been around for a long time. The newly found scarps are comparable in size to very young fault scarps identified on the lunar surface, which have all been attributed to the shrinking of the moon. Active faulting, paired with evidence for ancient faulting, and also the recent discovery that Mercury's global magnetic field was present for billions of years longer than previously thought, all combine to offer consistent support for the long-lived slow cooling of Mercury's still hot outer core. Slip-along thrust faults associated with small lunar scarps is possibly connected to shallow moonquakes detected by seismometers deployed during the Apollo missions to the lunar surface in the late 1960s and early 70s. Some of these moonquakes reached magnitudes of nearly 5 on the Richter scale. Scientists say seismometers deployed on Mercury in future missions would likely detect Mercury quakes associated with ongoing slip events on small faults and reactivated older large faults. Rosetta's mission to comet 67P Churyumov-Gerasimenko is finally over. The probe's final signal was received at the European Space Agency's Mission Control Center in Darmstadt, Germany at 11:19 Greenwich Mean Time. With a 40-minute signal travelling time from the comet, it means the spacecraft crash-landed on 67P's surface at 10:39 GMT, just 1 minute earlier than originally predicted. Rosetta's massive 12-year mission included many notable firsts, including becoming the first spacecraft to orbit a comet and the first to place a lander on a comet's surface. The decision to end the mission was brought about because as the comet's 6-year orbit takes it out towards Jupiter, it loses a significant amount of the sunlight needed to power the spacecraft's solar arrays. During its historic mission, Rosetta discovered more than 60 molecules, 34 of which had never previously been found on a comet. These included oxygen and the amino acid glycerine, a basic building block of life. Rosetta also confirmed that Earth's water didn't come from comets, but rather more likely from asteroids. Detailed images obtained by the spacecraft successfully mapped the comet's craggy frozen surface, finding over 25 distinct regions with different morphologies. These included steep slopes, large depressions and small cavities from which material seems to flow, and flat-looking areas that display similar features to sand dunes. During Rosetta's 14-hour suicidal descent to its ultimate death, the spacecraft continued sending new observations until the signal finally went off. The end of the Rosetta mission does not mean the end of cometary analysis. Far from it. Scientists still have years of work ahead of them, sifting through the stacks of data collected during Rosetta's 2-year orbit. In fact, some science instruments have as little as 5% of their total data output analysed. Meanwhile, brief but powerful outbursts seen on comet 67P Churyumov-Gerasimenko during its most active period last year have been traced back to their origins on the surface. During the 3 months centred around the comet's closest approach to the Sun, back on August 13, 2015, Rosetta's cameras captured 34 outbursts. A report in the monthly notices of the Royal Astronomical Society claims these violent events were over and above the regular jets and flows of material normally seen streaming from the comet's nucleus. The latter switch on and off like clockwork repeatedly from one cometary rotation to the next, all synchronised with the rise and fall of the Sun's illumination. By contrast, the new outbursts are much brighter than the usual jets. They're sudden, brief, and involve high-speed releases of dust. They're typically seen only for a single image, indicating they must have lifetimes shorter than the interval between images, which typically is anywhere between 5 and 30 minutes. A typical outburst is thought to release between 60 and 260 tons of material during those few minutes. On average, the outbursts around the closest approach to the Sun occurred about once every 30 hours, which equates to about 2.4 comet rotations. Based on the appearance of the dust flow, they can be divided into 3 broad categories. One type is associated with a long, narrow jet extending far from the nucleus, while the second involves a broad, wide base that expands more laterally, and the third, well, that appears to be a complex hybrid of the other two. Because any one of these outbursts is very short-lived, only captured in a single image, scientists can't determine if these 3 types of plume shapes correspond to different mechanisms, or if they're just different stages of the same process. Now, if it is just one process that's involved, then it seems an initial long, narrow jet with dust is ejected at high speed, most likely from a confined space. Then, as the surface around the exit point is eroded and widens, more fresh material is exposed, broadening the plume base. And of course, once the exit point is widened enough, the narrow jet disappears, leaving behind a far broader plume of cometary material. Interestingly, just over half of all these events seem to occur in regions being warmed by early morning sun after many hours of darkness. The rapid change in temperature could be triggering thermal processes which lead to fracturing of the surface, exposing volatile material below, causing it to heat up and vaporize explosively. The other events occurred after local midday on that part of the comet, when the area has been heated for several hours. Scientists think the growing heat reaches deeper and deeper into the comet, where it eventually starts to affect pockets of buried volatiles, again causing an explosion. Adding complexity to the issue is the fact that most of the outbursts seem to originate from regional boundaries on the comet, places where there are changes in the texture or topography of the local terrain, such as deep cliffs, pits or alcoves. The fact that boulders and other debris are also seen around the regions identified as the sources for the outbursts confirms that these areas are particularly susceptible to erosion. So, while eroding cliff faces are thought to be responsible for some of the regular long-lived jet features, a weakened cliff edge could spontaneously collapse at any time, suddenly revealing substantial amounts of fresh material which could cause an outburst even when the region isn't exposed to sunlight. In fact, at least one of the events studied took place in local darkness and therefore could be linked to cliff collapse. By studying how these phenomena vary as the comet progresses along its orbit around the Sun, scientists are achieving new insights into how comets evolve during their lifetimes. Over the last few days, AR 2597, the last remaining sunspot group on the surface of our local star, the Sun, has disappeared. The blank solar face, the fourth this year, is a clear sign that the Sun's 11-year solar cycle is now heading towards solar minimum. But we still have a long way to go. Solar minimum isn't likely to occur until 2019 or 2020. What makes this event more interesting this time round is the fact that we're coming out of the weakest solar maximum in 100 years, with NASA describing it as the smallest solar max of the space age. Every 11 years, the Sun goes through a cycle of increasing then decreasing solar activity associated with a change in the Sun's polarity. Put simply, the Sun's north and south magnetic poles flip. The magnetic south pole becomes the north pole, and the magnetic north becomes south. The event's associated with a steady increase in sunspot activity, resulting in a corresponding increase in eruptions of energy and plasma from the Sun's surface, known as solar flares, and even more powerful blasts of stellar material into space called coronal mass ejections. When these space weather events hit the Earth, they produce geomagnetic storms, which slam into the Earth's protective magnetic field or magnetosphere, causing it to wobble like jello. These solar storms send charged particles, ionized protons, electrons and helium nuclei, streaming along Earth's magnetic field lines, in the process producing spectacular northern and southern lights, the aurora borealis and aurora australis. However, these same charged particles have often overloaded terrestrial electrical transmission grids, damaging equipment and causing widespread power blackouts. They also affect radio communications and navigation systems, causing airlines to reroute aircraft away from polar flight paths. These space weather events can also damage delicate spacecraft electronics, and they pose a serious radiation threat to astronauts. The increased solar activity also heats up Earth's upper atmosphere, causing it to expand, which increases atmospheric drag on orbiting spacecraft, and that causes them to need to use more fuel to prevent orbital decay, consequently shortening their service lives. The good news is that it also slows down low-altitude space junk, causing it to re-enter and burn up in Earth's atmosphere much sooner. Solar Cycle 24 began in 2011, peaking in 2013 with far fewer sunspots, solar flares and coronal mass ejections than usual. However, the ones that did occur were every bit as intense and powerful as the more frequent solar storms the Sun normally produces during solar max. Over the next few years, periods of no sunspots will steadily increase in duration, initially lasting just a few days at a time. However, eventually these periods of a blank solar face will stretch out into weeks and then months at a time. Solar minimum causes a drop in ultraviolet radiation from the Sun. That in turn causes Earth's upper atmosphere to cool and contract. Space literally gets a little bit closer to the planet's surface. And the Sun's extended atmosphere, the heliosphere, also contracts a little, allowing cosmic rays from beyond our solar system to penetrate deeper into our neighbourhood and consequently deeper into Earth's atmosphere. Time now to turn our eyes to the skies with Skywatch for October. And we start with a question. You've probably heard of a blue moon, the rare occurrence of a second full moon in the one calendar month. But have you ever heard of a black moon? I certainly haven't, at least not until now. Apparently, a black moon only occurs when there's a second new moon in the same calendar month. Of course, the new moon isn't visible because it's between the Earth and the Sun, with the dark side of the moon facing the Earth. And in case you didn't notice it, with the first new moon of the month occurring on October the 1st Greenwich Mean Time, a second new moon will take place on October the 30th. So, according to this definition, that's a black moon. But the term black moon is far more confusing than that. Apparently, a black moon can also refer to the third new moon in a season with 4 new moons, the absence of a full moon in a calendar month, or even the absence of a new moon in a calendar month. In Wicca, some believe the black moon is considered to be a special time when any rituals, spells or other workings are considered to be more powerful and effective. However, others believe that any rituals or workings should not be conducted at these times. It's all very confusing. Also this month, there are 3 meteor showers, the Draconids, the Taurids and the Orionids. The Draconids take place on October the 8th. They're so named because their meteors appear to radiate out of the constellation Draco the Dragon. As a result of this, they're best viewed from the northern hemisphere. They're actually produced as the Earth's orbit takes the planet through the debris trail left behind by the comet 21P Giacobini-Zinner, which takes about 6.6 years to orbit the Sun. Then there's the Taurids meteor shower, which takes place on or about October the 10th. And as their name suggests, they appear to radiate out of the constellation Taurus the Bull. Interestingly, these meteors are composed of larger than average pebbles and dust grains, and are thought to be generated by debris produced by the comet 2P Encke. Although it's also thought that both the Taurids and Encke could be the remains of an earlier comet which disintegrated over the past 20,000 to 30,000 years, breaking into several pieces and releasing material both by normal cometary activity and also possibly by gravitational tidal interactions with the Earth and other planets. The Taurids debris stream is also the largest in the inner solar system, taking the Earth several weeks to pass through it and resulting in an extended period of meteor activity compared to other meteor showers, which are usually over in just a matter of days. Now, due to the gravitational perturbations of the planets, especially Jupiter, the Taurids are spread over such a wide period of time that it's been labelled in two separate segments, the northern Taurids and the southern Taurids, which are observable at different times in different hemispheres. The southern Taurids, obviously observable in the southern hemisphere, are active from about September the 10th to November the 20th, while the northern Taurids, for those north of the equator, are active from about October the 20th to December the 10th. Our third meteor shower of the month is the Orionids. Jonathan Nally is the editor of Australian Sky and Telescope magazine.
What is normally one of the year's best meteor showers is around during October. It's called the Orionids because the meteors seem to come from the direction of the constellation Orion. And this year, the maximum number of meteors might be, say, one every 5 to 10 minutes, and that'll be on the night of October 22, so overnight 21st, 22nd. Unfortunately, the moon will be up. And
It'll be a quarter moon, won't it?
Quarter moon, yeah, and the moonlight tends to drown out the faint meteors. So if you're already struggling, say, in a city environment where you've got a lot of light pollution from streetlights and things, and the moon's up as well, well, you're perhaps not going to see a meteor every 5 to 10 minutes. You might see a few per hour or something. If you've got a darker location, you certainly might see more. The other thing, too, is that like most meteor showers, that happens in the wee hours of the morning, so best time to look for these meteors is in the few hours prior to dawn.
And of course, the Orionids is spectacular because it comes from the comet Halley, which also causes the Eta Aquarids meteor shower in May.
There's no doubt about that comet Halley. I mean, I saw it when it was around in the 80s. I don't know if I'm going to get to see it in 2061. I'll be a pretty old man by then. But at least, if you don't think you're going to be around by 2061, you can go out and see these meteor showers and still see bits of Halley. If you have dark skies, at the moment you can see our galaxy, the Milky Way, stretching right across the sky from southwest to northeast during the early part of the evening. I say dark skies because the Milky Way is fairly faint, and for those of us who live in cities, well, you're really struggling to see it, if anything at all. You really need country skies these days. You don't have to go away into the outback, but just away from the city lights, and you can start to see the Milky Way. It's a real shame because 60 years ago, you could see the Milky Way from the big cities, but there's just too much light pollution now. Anyway, so the Milky Way is stretching across the sky, and the middle part of our galaxy, the Milky Way, is more or less right overhead still, and that's around the area of constellation Sagittarius. And right up there at the moment, it's been there for a while now, is the planet Mars, is right in the thick of it. Mars looks like a reasonably bright reddish-coloured star, although it is, of course, a planet. Now, speaking of planets, as we start October, the planet Saturn is about halfway up the sky in the west after the sun goes down. You really can't miss it either because it's a nice, bright, slightly yellowish-looking star in inverted commas, although, of course, it's a planet. And just across to its left is what is really a star, and it's a reddish-coloured one. That's the star Antares, which is the brightest star in the constellation of Scorpius.
The opposite of Mars.
It's the rival of Mars. Antares means the rival of Mars, yes. So Mars is up high and Antares is about halfway down the sky. So you can compare the two and see how they're very similar. Now, lower down towards the horizon is something you can't miss because it's the biggest, brightest thing in the sky apart from the sun and the moon, and that's the planet Venus. It's really, really big and bright at the moment, and it's a great time of the year, or this year at least, to see it. Now, Venus is going to get slightly higher in the sky each night as the month goes on until in the last week of October, you'll see, I mentioned Saturn and Antares before near each other, or Venus is going to come up right close to them, and it's going to make a nice triangle in the western evening sky. And in fact, that last week of October will begin with Venus just below a line. You can draw a line between the star Antares and Saturn. Venus will be just below that, and on the 28th, they'll be directly in line. The three of them will be in line. It will be a pretty specky sight, and in the days following, Venus will move higher above them. Now, for people who are in or around Sydney, and unfortunately this won't work for anywhere else or any other latitudes, in fact even longitudes, you're going to see something really spectacular on the night of October 30. There'll be a special treat because about 1 minute past 8 p.m. you're going to be able to watch as the International Space Station goes sailing straight through the middle of that triangle I just described, Saturn, Venus and Antares. Space Station will come up from the horizon and it will just go sailing straight through the middle, just nice and slowly. Should be a really specky sight. If you're as far south as Melbourne, unfortunately the station won't be, it will be above the horizon I think, but the sky will still be pretty light down there. For people up in Brisbane, I think it's going to be too low on the horizon. You might not see it. It certainly won't be sailing through that triangle. So anyway, if you're in and around the Sydney area, make sure you get out on October 30. Fingers crossed for some good clear skies. Now, two of the planets that are normally visible to the unaided eye are pretty much not visible for most of this month. Mercury and Jupiter are on or heading around to the other side of the sun from us, so they're lost in the sun's glare. Mercury will reappear in our evening sky out to the west in November, and Jupiter will start to make a reappearance low in the eastern sky in the morning, around about the end of October, and slowly get higher in the sky as the weeks go past. Now, for early risers, some of the best constellations of summer are beginning to make an appearance. So if you're up between midnight and dawn, look out to the northeast and you'll start to see constellations like Orion and Taurus and Gemini. They're full of really fantastic sights. If you've got a telescope or even just a pair of binoculars, you can start to see lots of great things in the sky. So as the next few months go by, those constellations will shift into our evening skies and be really well placed for viewing.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And finally for now, Blue Origin have announced details of a new super heavy lift launch vehicle. The massive rocket, called the New Glenn, will be designed in both 2- and 3-stage versions. The 2-stage variant will be almost 83 metres tall, while the larger 3-stage version will be just short of 96 metres. The reusable first stage will be equipped with 7 Blue Origin designed BE-4 engines, burning liquefied natural gas or methane and liquid oxygen. The engines will give the rocket some 3.85 million pounds of thrust at launch. The same engines will also power the new United Launch Alliance Vulcan rocket system, which is slated to begin flying in 2019 and will eventually replace the company's existing Atlas and Delta rocket launch systems, which use Russian-made rocket engines. A single BE-4 engine will also be fitted to the second stage of the New Glenn launch system, while a single BE-3 engine burning liquid hydrogen and liquid oxygen will power the upper stage on the 3-stage version. The BE-3 engine is also used on Blue Origin's reusable vertical takeoff and landing New Shepard spacecraft. The New Shepard will be used to take passengers and scientific payloads on suborbital ballistic flights to altitudes above the Kármán line, which at 100 kilometres, or 328,084 feet, is the official start of space. Blue Origin haven't released any payload capacity to orbital altitude details as yet. However, the new launch vehicle size places it firmly between the new SpaceX Falcon Heavy and NASA's new SLS rocket systems. While New Shepard's being launched from Blue Origin's West Texas facility, New Glenn will fly from a new pad now being built on the site of Space Launch Complex 36 at the Cape Canaveral Air Force Base in Florida. The maiden flight of New Glenn is slated for 2020. By the way, the launch vehicle is named after John Glenn, the first American to orbit the Earth, in the same way that the company's New Shepard rocket is named in honour of Alan Shepard, the first American in space. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, and from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C.
This is SpaceTime with Stuart Gary. For more, you can follow us on Facebook, Twitter and Tumblr. Just search for SpaceTime with Stuart Gary.
SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine. This month, looking at whether the next generation of supercomputers will be able to handle the mega streams of data expected from the next generation of giant telescopes like the Square Kilometre Array.